Okay, guys, welcome. Today we're going to talk about the idea of fast exponentiation. Now, the idea behind fast exponentiation is that when we're looking at z mod n, we compute a number to a power more quickly than expected. Okay, and of course, the idea of fast exponentiation is that when you compute a to some power of 2 mod n, right? So you square a, you do it again, you do it again. You get this sequence of a to the powers of 2, right? So you get a squared, a to the 4th, a to the 8th, a to the 16th, blah, 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 blah. Now, each time we square the previous result and we get some number a to the 2l, it will, of course, go past n at some point. And you find that 2 times this l gives you some k mod n because you went past n, right? And we're in the world of z mod n. Now, as an example, let's look at something like 7 to the 256 power in z mod 1000, right? And of course, in terms of congruences, what you're really doing here is you're finding the last 3 digits of 7 to the 256. Now, normally this would be an extraordinarily huge number, and it would be impossible to do without the use of a pretty powerful computer. But since we're in z mod 1000, this isn't that bad to do at all. Right, so of course 7 squared is 49, which is fine. Now, if you square 7 squared, you get 7 to the 4th, then you have 49 times 49. And just to make this come out a little bit easier, you can separate this into 40 times 40, right, which of course is 1600. And then you have 2 times 9 times 40, which would see, so 2 times 40 would be an 80, and then times a 9 would be a 720, and then plus an 81. And of course, if you add all these together, you get 2401, which is 401 mod 1000. All right. Now, if we square that again, if we square 7 to the 4th, we get 7 to the 8th, which is 401, again, mod 1000 squared. Right, so now you see the advantage here. You had technically 2401, but instead of squaring 2401, since we're mod 1000, we just have to worry about squaring 401. Right, and of course, that's 400 plus 1 times 400 plus 1, just to make the arithmetic a little easier. Right, and you get 160,000, which mod 1000 is 0. Right, this is 0 mod 1,000, sorry. And we get 400 plus 1, which is just 801. So now when we square 7 to the 8th, we get 7 to the 16th. And again, that would normally be 160,801, but we just need to worry about mod 1000, so it's 801 squared. When we do that, we get 640,000, which is 0 mod 1000. And then we get 1600 plus 1, which is 601 mod 1000. And then if we square again, we square 601, get a 360,000, which is 0. 1200, which is 200 mod 1000, so we get 201. And then finally, when we do this one more time, we get 201 squared, which comes out to be 401 again. All right, and we already had 401 earlier. So now we don't have to keep doing the work because we know that when we square 401, the next step will be 801. And when we square 401, when we square 801, we get 601. We don't need to do the work again. So we can get quickly that 7 to the 128th is 801, and 7 to the 256 is finally 601 mod 1000. Right? So again, what this is really telling you is that if you do 7 to the 256 power, the last 3 digits are 601. Okay, now what if you have non-perfect square powers, right? So what if you have something like 7 to the 400? Well, then the trick is you just decompose 400 into powers of 2, right? So you can write 400, right? And you just use your addition rule for exponents. So you have 400 is equal to 256 plus 128 plus 16, right? And you can always do this. right? So then you get 601 times 801 times 601, right? And we know that 601 squared from before was 201. And if we multiply these together, you'll eventually find that this comes out to be 1 mod 1000, right? So if you have a number that's not raised to a perfect power of 2, then you just decompose it into numbers that are. All right, so this concludes the idea of fast exponentiation, and this is something that we're going to need when we study cryptography. All right, so I hope you enjoyed, and I will see you next time.